As Alban said, I will talk about the large-scale modeling and what happened on the wind farm area and what is the interactions between the different components and the marine dunes. Today, I will try to give you some insights about two main questions. So the first is what would be the cable installation work impact on the marine dune migration? And the second is what would be the monopile impact on marine dune migrations? So we just start with the cable installation work. For this study, I will focus on the small box you can see here around this box is located inside the cable corridor. And as you can see here, we have 6 large dunes across which the export cables for the Dunkirk wind farm will cross. So you can see here the real cable course of the 2 export cables of the Dunkirk wind farm. Real course for now, it could change in the future. So to install these cables, the most common way is to bury them inside the sediment to protect them from the marine environment. In our case, these cables should be buried under the moving sediment part of the seabed, as you can see here on this picture on the left. So the cable is buried under the marine dunes, so the dunes will pass over it without exposing them. That could lead to failure. So we want to avoid this case. To install these cables, so we have to do some installation work and particularly some trenching. So after we have estimated the burial depths, recommended burial depths, we have modified our bathymetry, as you can see here, to include these trenches. So you can see following the 2 white dash line here, the trenches, and the modification is here. So you can see on the northern part of each cables, we have to dig for 2 or 3 meters to install the cable to let the marine dunes passing over it. And instead of removing this sediment from the area, as it should be done in reality, the sediment is just moved on the west of each trenches, 30 meters west of both. This is to account for the natural migration that occurs in this area, which is eastward. So in this way, the deposit should refill the trench within a short period. So it is done to avoid, to minimize the environmental impact of these installation works. But what happened when we do that in our marine dunes? I will not describe the whole numerical model, but just to let you know that the modeling was performed using the Croco hydrodynamic model, coupled with the USGS sediment module for the sediment transport. And I will not show you this here, but in our case, we also do hydrodynamic and morphodynamic validation against in situ measurements. But I do not have enough time to show you all of this. We just keep it. So when we run our simulation for 1 year, we want to see what happened to the crest lines. So on this figure, you have the position of the crest lines of our 6 dunes. So in black, you have the initial position of each crest lines. In blue, the position when we do not have any cables, so the natural position of our dunes, and in red, their position when we consider the trenches. So as we can see, when the dunes are too far or located too far from the trenches, there will not be any impact on our dunes. The most impact will be on dune D3, D4, and D5. And as we can see, the proximity with the trenches change their migration speed, and in particular we can see here on D5 that's the crest line of this dune is located further east compared to the baseline case when we do not have any cables. We can see the same similar pattern here on the southern part of D3 and also on the northern part of D4. And we also have a part here where the migration seems to be reduced, the migration speed. So to understand what happened, we look at different transects, and here we focus on this middle transect. And as you can see, it crosses the 3 dunes, and we'll see what happened to understand each process. So here on this figure, you have the initial bathymetry. Just to let you know, I will not talk about bathymetry on these figures, but of dune topography. A simple way to understand that is when you have positive value, you are on the crest area, around the crest of the dunes. When you have negative values, you are around the trough area of each dune. You can see here, for example, D3, we have a positive value on its crest. So here on this figure, you have all 3 dunes that are designed by the highlighted. And we have our 2 trenches. Here we have the western trench, which is represented on the full black lines here. The trench and the deposit, the associated deposit. And here we have the eastern trench and the deposit here. So what we have estimated with our model is that the impact of the dunes is divided in 2 phases. The first phase is when the seabed adapts to the bathymetric modifications. We can see here what happened after 1 month. We can see that each deposit starts to fall inside our trenches and start to refill it. So it should leave 1 month to perform the final installation work for the cables, which should be enough. And after 3 months, we can see that both trenches are almost completely refilled. And so these trenches are really refilled within a short time period. After this initial period, we have both trenches that starts to behave differently. For example, when we look at the eastern trench, we can see the western trench, sorry, we can see that the deposit is reduced in height. And after 6 months, we can see that it has completely disappeared, and we do not see any trace of the installation work. This is because the Dune 3 here has absorbed the mass of the deposit, and it results this plain area where we have no trace of it. And when we look at what happened after 1 year, and when we compare the results with the cable in the plain line and without the cable in dash line, we can see that indeed the D3 dune is larger than it is in the baseline case. So it has absorbed the deposit. On the eastern trench, we can see a similar pattern. When we compare the D5 crest height, we can see that without the cable and with the cable, sorry, the crest height is lower. So the deposit start to act like a natural dune and start to absorb some mass of the D5 dune. But also, since both of it are of an equivalent height, the recirculation, the recirculation that happened just downstream this deposit, so this new dune, will have a repulsion effect on the D5. So the D5 dune will move further to the east compared to the baseline case. Now, when we look at what happened when we put a monopile inside inside our study cases, So this work is not mine. It's part of a PhD thesis done by Noémie Durand, who will defend her PhD next week. Using the Telemax system, the modeling was performed over a large scale. You can see here an extraction of the numerical grid. And by looking first at what happened on the same box as presented you before, we will see that what happened when we put a monopile. So to represent the monopile, this is simple. We just consider it as a land point. So it's like a micro island or maybe a rock, because it's a numerical cell that is 10-meter wide. And it is located here on the red circle. And here on this picture, you have the bathymetry changes that is calculated by the difference between the bathymetry without the cable and the bathymetry without the monopile, sorry, and the bathymetry with the monopile. So what we see is that upstream and downstream, you have the current direction here. Upstream and downstream on the western and eastern part of the monopile, we have the areas where the sediment will start to accumulate. So we have accretion areas because the current is highly reduced because of the presence of the monopile. While on the side of the monopile, on the northern and southern part of it, we have an acceleration of the current. So we have two erosion spots where the sediment will be moved more intensively, sorry. What is interesting to see is what happened when we look at the crest lines of the surrounding dunes when we put a monopile. You can see here the crestline position, the initial crestline in dark here, for example, for this dune. The brown lines represent the crestline after 1 year when we do not have any monopiles, and the orange line represents the crestline position when we consider the monopile inside our simulation. And as you can see here on this picture, the crest lines seems to be attracted by the monopile. We can see, for example, for this dune here, without the monopile, we have a straight line here, but with the monopile, you can see this this form that is done here because of the monopile here. To explain this process, we can look at, I'm sorry, okay, we can look at this schema to understand what happened. So if we look at the right side here, so when we do not have any monopiles, there is an eastward migration, so an eastward sediment transport, and the initial crest line that is in black here will be positioned here which is represented by the brown dash line after 1 year. However, when we have the monopile inside its wake, the current during the flood period, when the current are eastward, will be highly reduced. So the sediment transport inside the wake of the monopile will be highly reduced for this part of the dune crestline. And when the tidal current turns and change in direction and go westward, the current will push this part of the crestline towards the monopile. On the opposite side, this is the opposite that happened, but it's similar. There was also numerical modeling that was done using an array of monopiles. So here you have the 46 monopiles of the future wind farm. And we can see that the similar process are observed. We can see the crest lines are attracted with the closest monopile here in their wake. That's all I have for you today, and I thank you a lot for listening.